Hello students, a very good morning. Welcome to Misostudy. Today I am going to discuss few interesting, important and slight confusing topic related to chemistry, and I promise you it will help you a lot while solving the question for JEE Advanced as well as JEE Main and NEET. So friends, let's start the topic. My first topic is stoichiometry. I know this is one of the most toughest topic and slight confusing. I will promise you that I am here to give you few tips, techniques and different method to solve the question. So friends, let's start the session with a new topic, with a fresh topic, that is stoichiometry. Now listen carefully. If anyone asks you, what do you mean by stoichiometry? That is, suppose if I take a reaction A plus B which gives C, to find the quantities of reactant or products or to find the quantities of unknown substance is known as stoichiometry. That is the calculation involving in a chemical reaction is known as stoichiometry. Clear? For example, if I write here N2 plus 3H2, it gives 2NH3. Am I right, my friend? Yes, sir. Now link them. First of all, mole, here is 1. We can write here 1 mole N2 plus 3 mole H2. That is 2 mole NH3. When we relate the mole of reactants and mole of product, that is known as mole-mole relationship. That is, again we can write N2 1 mole, that is the molar mass of N2 is 28 gram. 28 gram N2 plus hydrogen, the molar mass is 2, that is 3 into 2, 6 gram H2. Then in case NH3, that is the molar mass is 17, my friend, that is 17 into 2, 34 gram of NH3. And this is what is mass. This is the mass relationship. So there are a number of relationships which I will going to discuss in the topic stoichiometry. Now, what are the relation? How to relate them? I'm moving here. Check it out what I'm telling. Look at. The first one is, give me few seconds, friend. Let me draw the figure. Now, this is the relation. First of all, mole of unknown. Mole of unknown and mole of known. As we know, look at. As we know, 1 mole is equal to molar mass. Yes, sir. First relation. Now, second one is, as we know, 22.4 liter is equal to 1 mole. And particle 6.022 into 10 to the power 23 particle, that is units, maybe atoms, maybe molecules, is equal to, my friend, 1 mole. Similar is the case, that is Here is 1 mole is equal to molar mass. Here is, we know, 1 mole is equal to 22.4 liter, and here is 1 mole is equal to, we can say, 6.022 into 10 to the power 23 atoms or molecules or any units. Now, how to link them? Mole is related to mass, mole is related to volume. So, if this is a known substance and this is an unknown substance, what is the first relation? Look at mass relation, mass volume relation, mass particle relation. Now, volume mass relation, volume relation, particle relation, again particle mass relation, particle volume relation, particle relation. By using this table, you can relate the quantities by using mass, volume, particles as well as mole, and this will help you a lot while solving the question in competitive examination. Now the time has come. I am giving you a technique to solve the question, how to attack on the question, that is the problem solving strategies. I am taking a simple example of stoichiometry and will help you to solve the question by using different methods. Look at what I am telling, listen carefully. I am moving here, check it out. My first question, I am starting with a simple question, that is, calculate the mass of O2 produced. Clear? Calculate the mass of O2 produced by 1.23 gram of KClO3. This is the question. Again I am repeating, question is calculate the mass of O2 produced by 1.23 gram of KClO3. Now how to solve this question? Look at, this is method number 1 and this method is simple method. Okay, how to solve? First of all, write down the equation. What is given here? That is KClO3. After decomposition, it gives KCl plus O2. Now balance the equation. Put here 2 and put here 2 also and put here 3. Now look at, relate, this is the known and this is unknown. Now relate them first of all with mole. Here is 2, that is, put here 2 mole of KClO3 gives 3 moles of O2. Am I right? Yes, sir. Now what we need? Mass relationship. As we know, 1 mole is equal to molar mass. What is the molar mass of KClO3? Sir, the molar mass of KClO3 is 122.5, because we know the atomic mass. After adding we can get the answer. So we'll write here 2 into 122.5 gram KClO3 gives you 3. What is the molar mass of O2? Molecular mass, that is 32 gram O2. Now what is given in the question, my friend? 1.23 gram. Now put here 1.23 gram KClO3 gives you, tell me, 3 into 32 multiply 1.23 divided by 2 into 122.55. This is a simple calculation. Now what will happen? This will cancel this one, that is 16. Now it can be written like this, 1.23 into 10 to the power 2. Yes sir, we can write. I have discussed this during the chapter number 1. Some basic principle, significant figure, rounding of a number and scientific notation. Now look at, this will cancel this one. Now what will happen? 16 3, 48 divided by 100. Clear to you? The answer is 0.48 gram O2. Clear? Now you can ask me, sir, what is nothing? What is special in this question? This is a simple method. We all are familiar with this solution. So what you are giving me the special thing. Okay, I'm moving here, friend. Wait and watch. Now, the next method is my friend, that is the second method for same question. Please give me few time. That is the method 2 for the same question, and this method is by using direct formula. This is the second method for the same question. Look at the direct formula, that is the mass of unknown is equal to mass of known is equal to the coefficient of unknown and the molar mass of unknown divided by coefficient of known and molar mass of known. Again I am writing, again I am discussing. This is the mass of unknown. Listen carefully, friend. Mass of unknown, and this is mass of known. Mass of known substance. Yes, sir. Now, this one is coefficient of unknown. Clear to you? And this one is, that is the molar mass or molecular mass, you can say, of unknown. Am I right? Yes, sir. And this one is coefficient of known. Coefficient of known. Yes, sir. Definitely. You are correct. Now, this one is, that is the molecular mass of known. Am I right? Yes, sir. You are absolutely right. Clear? Now put the value. That is UZ, mass of unknown, is equal to kg. What is given here? 1.23. Put the value, my friend. 1.23. What is the coefficient of unknown? That is, unknown is O2. Put here 3, my friend. What is the molecular mass oxygen? That is 16. Divided by, what is the coefficient before KClO3? It is 2. And what is the molecular mass of KClO3? 122.5. It can be written like this. Tell me, sir. 1.23 into 10 to the power 2. Now, what will happen? Check it out. This will cancel this one. And this is the representation, and this will cancel. One more thing, do I need to check few things? Okay, now that is 2, coefficient before 2, 3 by 2, 1 by 2, 3, that is, here is 2. What is the coefficient over here? That is 2 KClO3, and Ug is equal to Kg Cu Mu. What is the molecular mass? 16 into 2. Molecular mass of oxygen is 32. That is, this will cancel this one. That is 48 upon 100. That is, my friend, 0.48 gram. This is the another method to solve this question. Wait for a moment. Give me few seconds. Now moving to solve the third method. I am moving here. Now, method third. This is known as, again, an interesting method. This method is known as, my friend, magic number method. How to solve this question? Magic number method. What will happen? Listen carefully. First of all, put here KClO3. It gives you KCl plus O2. Balance them. 2. Put here 2. Clear? Now what will happen? Wait for a moment. Magic number, that is, let the magic number is X. Now, KClO3, KCl and O2. Visible? Is it visible to you? Then put here balance 2, 2 and 3. Now, let assume X is the magic number. Put here X, put here X and put here X. Clear to you? This is the thing. This is the technique. Now, what is the molecular mass of KClO3, that is 122.5. Put here 122.5. And what is the molecular mass of O2? That is 32. Put here 32. Am I right? Now what is the technique? Look at 122.5 multiply 2x is equal to the given mass. What is given mass, my friend? 1.23. Okay? Yes, sir. Now what will happen? That is x is equal to 1.23 divided by 122.5 multiply by 2. Am I right? Yes, sir. This will cancel this one. That is, it can be written like this, 1.23 into 10 to the power 2. So what do we get? X is equal to 1 upon 200. This is, my friend, the magic number. Now put this value here. I promise you will get the answer. Look at, we can say now mass of O2 is equal to 32 into 3x. 3 upon 1 up 3 multiply 1 upon 200. This will cancel this 16 and 100. Now look at 16 3. That is the 48 divided by 100. Again what we get, my friend? 0.48. This is the third method of the same question. Wait for a moment, friend. Give me few seconds. I am giving you a fourth method. Now I am moving here. Check it out. The fourth method for this question is one of the most powerful method to solve the questions related to stoichiometry. Look at. This is the method number 4, and this method is very close to my heart, friend. This one is principle of atomic conservation, and this law follow the law of conservation of mass. Now this is principle of atomic conservation, and it says that, first of all I am discussing the law. It says that mass of the atoms of reactants, mass of the atoms of reactants is equal to the mass of atoms of product, my friend. I have less time, so I will try to cover maximum topic, maximum confusing topic. You can say, or number of atoms of reactant will be equal to, in terms of atom, number of atoms of product. This is the statement, and completely it obey law of conservation of mass, my friend. That is, mass can neither be created nor be destroyed. Now how to use this method? That is, the question is given, that is KClO3. It gives KCl plus O2. Why this method is close to my heart, my friend? Because if you do not know how to balance the reaction, then for this method you do not need to balance the reaction. Without unbalanced reaction, without the balanced reaction, that is, by using unbalanced reaction, you can get the product. Because there are maximum number of questions in which a student feels that is not possible to balance the reaction, and it will take lots of time. So as we know, we are facing competitive examination and we have a very less time, and within this time frame we have to solve the question. So POAC, in POAC method we do not need to balance the reaction. Now check it out how to apply. Look at which one is known. This one is known. Which one is unknown? This one is unknown. Mark them. Now what will happen? Listen carefully what I am telling. That is KClO3, which is common in KClO3 and O2, that is the oxygen. Here 1 mole of KClO3 contains 3 mole of oxygen atom. Am I right? Yes. Put here 3 in like this, 3 into moles of KClO3 gives you 2, that is 2, because 1 mole of O2 contains 2 mole of oxygen atom, multiply 2 into moles of O2. Am I right? Yes, sir. You are absolutely right. As we know, what is the mole? Mole is equal to, sir, given mass upon molar mass. What is given mass, my friend? 1.23. What is the molar mass? 122.5. And 2. What is given mass of O2? We do not know. That is, we need to find what is the molar mass of O2, sir, 32. Now what will happen? This will cancel like this one, because it can be written like this, 1.23 into 10 to the power 2, my friend. Am I right? Now what will happen? This will cancel this one, that is 1 upon 16. So I am moving here, check it out. Is it visible? Now that is, I need lots of space. So wait for a moment. Now put here 3 divided by 100 equal to W upon 16. So W is equal to 48 upon 100, my friend. W is equal to 0.48 gram. Again we got the answer. So for this question we have 4 methods. Now the question arises, sir, why are you solving the same question by using different method? That's the question. As we all know, friend, we people think that competitive examination is tough. No, this is wrong. Competitive examination is not so much tough. That is the approach matter. We know we have a strong theory, but we do not know how to use this theory and how to approach the question in a fixed interval of time. Because in competitive examination, we have only 3 hours to solve around 90 questions for JEE Main and around 180 questions for NEET examination. That means to say we need a short technique, a special technique to approach the question, because one question have only hardly 60 to 70 seconds. And we people think these are so much tough. No, friend, these are not so much tough. It matters the approach, how we approach. Sometimes we do not score good marks in competitive examination. The reason, we have a strong theory, we are talented. I know you people are very much talented, but the approach. If you have time-saving theory, then you can solve the same question within a fixed interval of time, within less time. That is the thing. So that's why I have discussed the 4 methods. And it's up to you which method is short and which method is easy for you. So for a single question, you may have more than 2, more than 3, more than 5, 4, more than 5 types of method. So friend, what I am telling, change your approach. I know I am very much talkative, but friend, I think it will help you a lot. I know I am not very much talented. My session is not so much engaging. But I promise you, after the end of this session, there is a smile in your face, my friend. It will create the difference. Because today you will feel that there is a difference. Clear, friend? Now, I am not wasting time. I am moving to the next powerful topic, next confusing topic, that is limiting reagent and percentage yield. So, I am going to wrap this part. Okay, friend? Wait for a moment. Give me few seconds. I am doing fast. Otherwise, my camera friend will tell me, sir, time is approaching, do fast, do fast. Wait for a moment. Now, my next topic is limiting reagent, my friend, limiting reactant. How to find the limiting reactant. And I promise, again, I will give you more than 2 solutions to hammer, to seal the target. Now, the next topic is, next confusing topic is how to find the limiting reagent and percentage yield. That is limiting reagent and the percentage yield. Clear to you? Now, what is limiting reagent? We people know which consumes completely in a reaction. Now, I am taking an example. By this example, you can easily understand how to use, how to find the limiting reagent. Now, look at, here is given N2. When nitrogen and hydrogen combine, it gives ammonia. If I have 50 gram of nitrogen and 10 gram of hydrogen, then tell me which one is the limiting reagent. Clear? That is the question. Now, first of all, method 1. Method 1. Method 1, as I told you, first of all, I will start with simple method. Now put here, that is a simple method. What is the definition of limiting reactant or limiting reagent? the reagent, the reactant which consumes completely during the reaction and decide the product. Clear? To decide the quantity of product. Now check it out. As we know, the molar mass of nitrogen is 28 gram. Now look at 1 mole N2 combined with 3 mole of H2. Yes sir, definitely 1 mole is equal to 28 gram, that is the molecular mass. 28 gram N2 my friend combined with 3 into 2, 6 gram H2. Clear? Now what is given here my friend? 50 gram N2. 50 gram N2 will give you around 3 into 2 multiply by 50 divided by 28. Clear? That is 14. 50 upon 14. It will be the value around 10.71 gram. Around. That is what is given here. 50 gram N2 gives required 10.71 gram H2. But here the quantity of H2 is only 10 gram. That means to say O2 is consumed completely in the reaction. If a reagent, if a reactant consumed completely in a reaction, we say that is the limiting reagent. Am I right? Yes sir, you are absolutely right. Now modifying the question. When 50 gram, 10 gram, 50 gram of N2, 10 gram of H2 combine, they gives 45 gram of NH3. That is the question. That is the actual quantity. Now tell me the percentage yield. Now what is given here? We find it out, that is H2 is the limiting reagent. That's why it will decide the quantity of product. Now let's move. Now we need to balance also, and to put here 3, put here 2, as I've done these things here. Now look at, I'm moving here, check it out. 3 mole H2 gives you what is 2 mole NH3. Am I right my friend? 3 mole H2 gives you 2 mole NH3. Now what will happen? 3 into what is the molecular mass? 2. That is 6 gram. H2 gives you 2 into 17, that is gram NH3. Am I right? What is given here? We have only 10 gram. 10 gram of H2 will give you 1734. Clear to you? That is multiply by 3 to 10 divided by 6. Clear? Again, let me check these things again. Okay. That is, what is the value? 34 into 5, 20, 5, 3, 15 to 17. 17 divided by 3, that is 3 5s are 15, that is 2. That is around, we get 10 gram H2 will give you 56.6 gram of NH3. Or you can say around 56.7 gram, because this is 56.66, this is NH3. This is the theoretical value. Wait for a moment my friend. This is the theoretical value and this is the actual value. And what is the formula of percent yield? Percent yield is equal to, my friend, listen carefully, actual yield upon theoretical yield multiply by 100. What is actual? According to the question it is given that is only 45 gram. Put here 45 divided by 56.7 multiply by 100. The answer is, my friend, 79%. Look at, this is the question. Now, this is a simple method. What is special? Now I'm giving you the next method. I'm moving here. Follow me, my friend. The next method, put here the method 2. And this method is by using magic number also. This is one of the most important, and this method is close to my heart, my friend. That is, look at, first of all, write down the reaction. N2 plus 3H2, it gives you 2NH3. This is the complete equation. Now, what is given here? Look at, so this is 50 gram, this is 10 gram, and this is 45 gram according to the question. Now, what magic number say? put here x, put here also x, put here also x. Now find the value of x. That is the thing. And look at what is the molar mass? 28. Yes, sir. What is the molar mass of hydrogen? That is 2. Wait. Let me use the colorful. We have a colorful chalk. Pardon, just kidding, friend. That is 17. Am I right? Yes, sir. Now, we know what to do. Put here 28x is equal to 50. Am I right? This is 50. Balance. X is equal to 50 upon 28. This is the value around come 1.79 around. That is, this is the magic number first. Mark it as a magic number first. Now for hydrogen, find it out. What will happen? 3 into 2, 6x is equal to 10. X is equal to 10 upon 6. It will have value 5 into 3. That is 3, 1, then 2. 1.66, almost 1.67. Mark it as a magic number 2. Now tell me, which magic number is less? Sir, this one. So what is the question, my friend? What is the answer? If the magic number is less, then that particular reactant is treated as limiting reagent. So it's so simple. We people can say that is H2 is a limiting reagent. This is another method to solve this question. If H2 is the limiting reagent, so it will decide the quantity of the product. Now, I am moving here, friend. I am moving from one corner to other corner. So, don't worry. You will feel better. Now, 1.67 put is here, that is, so what is the quantity of NS3 in this case? That is, we will put 17 into 2, and what is the value of X? That is 1.67. So, we can say mass of NS3 is equal to 17 into 2 into 1.67. It will give you a value around 55.67, or you can say 55.7. This is the theoretical mass. Now, how to find the percent yield? Percent yield is equal to, we people know, actual yield. What is the value is given? Actual 45 divided by 50, it is not 56, it is not 55, it is around, so after solving it is around 56.7. Now put here 45 divided by 56.7 multiply by 100. What do we get? The value is around 79%. Whatever the matter, the answer remain unchanged. It only matters the approach. If you have a solid approach, if you have a solid foundation, then you can solve each and every question. Clear to you? I have one more method, that is POAC method. But we have less time, so I am removing this and will discuss a question from IIT JEE 2017. Clear? Wait for a moment, friend. Give me few seconds. I think now you are very much familiar with the limiting reagent and with the percent yield. And we all know sometimes while solving numerical problems, we face problem which one is limiting reagent. By using the POAC method, by using the magic number method, or by using the simple method, you can find out the limiting reagent and excess reagent. Now, I am giving you a question. I am moving here. Check it out. This is a question from JEE 2017. Recent question. Now, last year question. What is the question? When, listen carefully, 1 gram of metal carbonate, when 1 gram metal carbonate react with excess of HCl, clear? When 1 gram of metal carbonate react with excess of HCl, wait for a moment, it gives CO2. Clear to you? It gives CO2, and the CO2 mole, that is 0.01186 mole of CO2. Clear to you? What is given here? It gives 0.01186 mole of CO2. The question now, find out the molar mass of metal carbonate. Clear? You can check. This is a question from JEE 2007. Now we have 4 methods to seal this target, to solve this question. So which method should I use? Okay, I am using the POAC method. Clear to you? First of all, write down the equation M2, because it do not require to balance the reaction. M2CO3 plus HCl, it gives you MCl2, clear my friend, plus H2O and plus CO2. And what to link? This one is now unknown, U, and this one is known. Clear? And we know we have to relate unknown and known. Now look at here, which one is common? Carbon and carbon. Which one is common? Oxygen and oxygen. It depends on you which you are taken into consideration. That is, here M2CO3 contains 1 mole of carbon atom. So we put here 1 into mole of M2CO3. Clear? Equal to CO2. In CO2 there is 1 mole of carbon atom. 1 into mole of CO2. Am I right? And this is the method POAC. Pay respect this principle of atomic conservation. It will save your time. As we know, mole is equal to given mass upon molar mass. Given mass we do not know. Given mass is given. Given mass is given. Molar mass we do not know. So put here 1 into 1 upon m. And what is the mole of CO2? 0.01186. Now you can get the answer within 30 seconds. Now what will happen? Sir, m is equal to 1 upon 0.01186. This is the answer. You can solve this question by using simple method, by using magic number method, by using direct formula also. What I am telling my friend, competition is not so much tough. That is the approach matter. If you have a solid approach for a question, then it will create the history. And we are here, my friend, to create the history. Allow me to serve you. Definitely, I will not let you down. Now, let's move to the next topic. The next slight confusing topic is I'm taking, that is some important points related to electron, proton and neutron. This is the topic from structure of atom. And maximum numbers of questions are asked from this topic, and this is time saving topic. Like, first of all, if anyone asks you what is isoelectronic species, clear my friend? The second one is, if anyone asks you define isotopes. We are familiar with isotopes also. We are familiar with isobars. Now, that is isotopic number. How to find isotopic number? Now, this one is isotones. Isoelectronic species. Clear, my friend? Isotopes, isotopes, isobars, isotopic number, isotones, isodiaphers. Isodiaphers. Clear to you? Isomers, so on. Now the question arises, frequently asked topics, that is, what is isoelectronic species? As the name tells, isoelectronic contain same number of electron. Species which contain same number of electrons are known as isoelectronic species. If I write here, for example, that is Na plus, Mg2 plus, Al3 plus, Ne, F minus, O2 minus, so on. Look at in Na plus, as we know, Na has atomic number, my friend, 11. Now it has 1 electron less, that is 10 electron. In Mg2 plus, atomic number 12, that is 2 electron less, that is 10. Here 3 electron lose, that is 10 electron here also. Here is also 10 electron. Here is also 10 electron. Here is also 10 electron. Minus, that is the gain of electron. Look at these all species contains equal number of electrons. So they are called isoelectronic species. Am I right? One more thing, by using this you can also relate the increasing or decreasing order of the size. If the pair, if the species are isoelectronic species, then how to arrange them in increasing or decreasing order of their size? As we know, more charge, more negative charge, then it will have more ionic size. Then if you arrange them, O2 minus will have maximum size, then there comes F minus, then there come nickel, and more the positive charge, that is less is the size. This is the technique. Plus is known as ionic cationic radius, and minus is known as, my friend, anionic radius. Minus will have more size in comparison to the plus one, in comparison to the cation. Maximum number of negative charge, maximum is the size. So O2 minus will have maximum size, then there come F minus, then there come neutral molecule, then comes, tell me which one? Sir, Al3 plus. Am I right? No sir, you are wrong. Na plus will come. Al3 plus will have less size because it contains maximum number of positive charge. So the order is, my friend, that is O2 minus, F minus, Ne, then there come Na plus, then there come Mg2 plus, and then there come Al3 plus. This is the order. By using one thing, you can solve maximum number of question, and this is a question from periodic table, and this is a question from atomic structure. You can relate each and every chapter. Friend, I have less time, I know, but I have a few extra topics. Definitely I will discuss this later also. First of all, let's complete these things, then we'll discuss another. What are isotopes? This is there is a question from this topic in JEE Advanced. What is isotopes? Listen carefully what I am telling. If I put here CO2 and N2O, look at, in CO2 there is 3 atoms, 1 carbon and 2 oxygen, 2 plus 1 3. In N2O there is 2 nitrogen atom and oxygen atom, that is 2 plus 1 3. They have equal number of atoms. Yes sir. Now check out the valence electron. As we know, carbon has atomic number 6. The valence electron is 4 here. And oxygen has atomic number 8, the valence electron is 6. Total number of valence electron, oxygen 2 times 6 to 12, 12 plus 4, 16 electron. Clear? I think my calculation is correct. Now for N2O, what is the atomic number of N2? That is 7. What is the valence electron, my friend? 5. What is the atomic number of oxygen? That is 8. What is the valence electron? 6. Now in N2O, how many number of valence electron? 2 times 5 into 2, 10. 10 plus 6, 16, my friend. That is, check it out. Both have same number of atom and same number of valence electron. If two molecules having same number of atom and same number of valence electron, then they are isotopes. Again, I am repeating, there is a question from this topic in JEE Advanced. That is comprehension type questions. I will discuss it later. So, if I write here CO and NO, check it out, whether they are isotopes or not. Listen carefully what I am telling. In CO, we people say the number of atoms 2, here is number of atoms 2. Yes sir. Now, count the valence electron. 4 plus 6, that is equal to 10 electron. Now in this case, what is 5 plus 6, that is 15 electron. 5 plus 6, that is 11. Pardon friend. That is, look at, in CO and NO, number of atoms are same, but the valence electron differs. If the valence electron differs, my friend, then we can say they are not isotopes. Clear to you? They are not isotopes. For isotopes, number of atom as well as number of valence electrons should be same. In many books it is given number of atoms and number of electrons. Which type of electrons, my friend? This is only valence electron. So check out your knowledge. then it will help you a lot. Now next one, I think you are familiar with this topic, isobars. This is simple one. We people know two molecules. If I write here argon 1840, then calcium 20 and 40. Look at, in this case, they have same mass number and different atomic number. Pair having same mass number but different atomic number are known as isobars. Am I right? Yes, sir. Now here is given what is isotopic number. Look at, this is one of the most important thing. Isotopic number, listen, this term is used generally in radioactivity, my friend. You can use these things in stable molecules also, but in radioactivity this term is generally used. Isotopic number, listen carefully. Difference of neutron and proton, that is difference of n minus p, is treated as isotopic number. If I write here a simple example, carbon 6 and 14, this is a radioactive element, and in this case tell me the number of proton. Proton is atomic number 6, neutron is, we know, mass number minus atomic number, that is 8. What is the isotopic number in this case? Sir, the isotopic number in this case 8 minus 6, that is 2. In case of C614, that is one of the isotopes of carbon, that is it will have isotopic number 2. So isotopic number is equal to n minus p. Now let's move here, that is where is isotopes? Okay, I have discussed the pardon, I didn't discuss the isotopes. Wait for a moment. Isotopes missing here. What is isotopes? Isotopes, if I write here, look at 6, 12, C6, 13 and 14. Look at, in this case they have same value of atomic number but different mass number. That is, if atomic number same and mass number different, they are, my friend, isotopes. Clear to you? So this is one of the isotopes of carbon and it is radioactive number, and isotopic number is n minus p, neutron minus proton. Now moving here, look at isotones. Do you have any idea about isotones? I'm moving here, check it out. Isotones. What are isotones, my friend? That is, sir, isotones is equal to having equal number of neutron. Species having equal number of neutrons are called isotones to each other. Clear? I'm taking an example. Let's check it out. C614 or how do you write here? 13 and N714. Clear? Check it out. In this case, what is the number of neutron? 13 minus 6, that is 7. Here the number of neutron 14 minus 7 is 7. So this is isotone. Clear to you? Now the next topic is, my friend, isodiaphers. Do you have any idea about isodiaphers? That is, pairs having equal value of isotopic number. What I am telling, pair having equal value of isotopic number. That is the neutron axis, that is pair having same difference of neutron and proton, and difference between neutron and proton is called as isotopic number. So pairs having equal value of isotopic number is known as isodiapher. This term is generally used in case of radioactive element, like if I write uranium, thorium, they forms pair of isodiapher. In isodiapher, what we need to check, we need excess, that is the isotopic number. Clear to you? And how to find the isotopic number? That is n minus p. Now you are familiar with this topic, I think, and why I am discussing this topic, because this is time saving and maximum number of questions. Generally 1 or 2 questions are asked from these topics in competitive examination, and this topic will save your time and will give you a maximum number. Clear? Now let's move to the next topic. Next confusing topic, my friend, is cause of radioactivity. I think during nuclear chemistry you faced this problem. What is the reason of radioactivity? Why elements emit, nucleus emit alpha, beta and gamma rays? I think I have around, how much time I have, my friend? Is it boring for you? I think it's not boring. You are getting these things quite easily. Okay, now the next one is, that is the cause of radioactivity. Cause of radioactivity. My camera person is also enjoying my lecture. I know. Wait for a moment, my friend. Let me discuss these things. That is, what is the cause of radioactivity? Listen carefully, my friend, what I am telling. Radioactive, that is, in radioactivity there is the involvement of nucleus. Am I right? Yes, sir. And in nucleus we people know there is neutron plus proton. So this neutron proton will decide the radioactive element. That is, which will decide the radioactivity? That is neutron, ratio of neutron and proton. If generally it is found that, if I write here sodium 1123, if I write magnesium 1224, if I write here that is carbon 612, if I write here nitrogen 7 on 14, what do we observe? We observe that N by P ratio equal to 1 or ranges between 1 to 1 by 3. And we people know these are the stable molecules. Yes, sir, these are the stable molecules. If these are the stable molecules and for them N by P ratio is 1 to 1.3. That is, if the N by P ratio ranges between 1 to 1.3, then they are stable molecules. They will not emit alpha, beta and gamma rays. For heavier molecules, this value changes to up to 1.6. So better to write here, if the N by P ratio, generally in case of stable molecules up to calcium, if the value we observe 1 to 3, 1 to 1.3, then we can say the molecules are stable, the nucleus are stable. But if there is decrement or increment, there is few heavier molecules, few stable heavier molecule where the value 1.6, but it is a special case. Generally 1 to 1.3. If the value increases or if the value decreases, then there is a existence of radioactive material, my friend. What I am telling, then there is a existence of radioactive material. And how to represent this by graph? Look at this. This is the last topic, friend. Wait for a moment. Look at, put here the graph between number of protons, am I right, and the number of neutrons. Clear to you? This shaded region is the stability zone, and stable nucleus lives here. Stability zone. Clear? Above this shaded region, there is a radioactive molecule. Below this, there is also radioactive elements. Clear to you? And this is a region here, that this is it says that N is equal to P. Number of proton is equal to number of neutron. So we have two regions, above and below. If above, that means to say N by P ratio is greater. If the N by P ratio is greater than the stability, so to gain the stability, that is we have to lose the n by p ratio. In this case, there is beta emission take place. Listen carefully. There is a direct question from this topic in NEET and JEE main examination. Again, I am repeating. If the n by p ratio ranges between 1 to 1.3, then they are stable molecules. But if the value increases or decreases, then there comes the existence of unstable molecule, that is the radioactive element. If n by p ratio is higher, greater, that means to say higher than the stability, then to gain the stability, to lose the n by p ratio, to decrease the n by p ratio, there is beta emission take place. Clear? What is beta? What is the symbol of beta? Y minus 1, 0. If I write here C614, that is the radioactive isotopes of carbon, it converts into 14, 7 nitrogen, and there is a emission of beta particle take place. Look at, in this case, what is the n by p ratio, my friend? 8 by 6. And in this case, what is the n by p ratio? 7 by 7, that is 1. Now here it has high value of n by p ratio, and it has now less. That is when we decrease the n by p ratio, then what will happen? In this case, the beta emission take place. If the radioactive molecule lies above the stability zone, so it will gain stability by beta emission, my friend. Now the question, if the radioactive element lie below the stability zone, that is in this case n by p ratio is not higher, n by p ratio is lower. In this case, we have to increase the ratio of n by p. And how to increase the ratio of n by p? Generally by positron emission. What I am telling, my friend, that is positron emission. What is positron? That is 0 plus 1e. By positron emission, you can increase the n by p ratio. Again, I am repeating, above beta emission, below positron emission. In case of artificial radioactivity, two more things, you can increase the n by p ratio, that is k electron capture also. And for natural, that is alpha emission also take place. By using alpha emission, the n by p ratio decreases. For example, uranium converts to thorium. Clear to you? For example, that is Au converts to Pt. Clear, my friend? These are the things. So now if anyone asks you what is the cause of radioactivity, n by p ratio. If n by p ratio is greater, is higher than the stability zone, then in this case the radioactive element will gain stability by losing beta particle. If the n by p ratio is less than the stability zone, in this case below the stability, in this case that is n by p ratio is lower. To increase the n by p ratio, that is there must be a positron emission. In case of artificial radioactivity, there must be a alpha emission in case of natural radioactivity, and the third one is K electron capture. I think now you are familiar with this topic. You can solve this type of questions quite easily. These are not so much tough, not so much confusing. These are slight tricky, and if you have a strong command over the theory, and you can easily solve the questions, my friend. I think now time is approaching, so I have to restrict my lecture with this topic. In my next class, definitely I will discuss few more interesting problem solving technique, that is from state of matter, chemical energetic, chemical equilibrium, and ionic equilibria, and it will help you a lot. So friend, one request, if you really like my lecture, then please allow me to serve you again. Do subscribe to Misostudy. Thank you so much. Bye-bye.